Dear children, today we can see some numericals from the collision. A 10 kilogram ball and 20 kilogram ball approach each other with velocities 20 meter per second and 10 meter per second respectively. What are their velocities after collision if the collision is perfectly elastic? So, you know the relation for finding the velocities in the perfectly elastic collision that we derived in the theory part. From the question we can write the mass of the two balls, that is mass m1 equal to 10 kilogram and mass m2 equal to 20 kilogram. Then the initial velocities of the first ball, that is u1 equal to 20 meter per second. And initial velocities of the second ball, u2 equal to second ball approach, that is two balls are approach each other. So the first ball move in the forward direction and the second ball moves in the opposite direction. So we can write u2 equal to minus 10 meter per second. Then we can find out the velocities after collision in the perfectly elastic collision. In the elastic collision, okay. That is V1 equal to formula V1 equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. Once again formula V1 equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. Then substituting the above values in the equation, we can get the answer. So we can substitute here, that is the m1, that is 10 minus 20 divided by 10 plus 20 into what is u1, that is 20 plus 2 into 20 divided by 10 plus 20 into minus 10. Then we will get the answer. After calculating all these, we will get the answer minus 20 meter per second. Clear? This is the velocity of the first ball after collision. Similarly, velocity of the second ball after collision, that is V2 equal to. So we can change the intercept of the first equation. So there you know that is the m1 minus m2. So we can write m2 minus m1 divided by m1 plus m2 into u2 plus 2m1 divided by m1 plus m2 into u1. Similarly, we can substitute the values here, then you will get the answer. So we can substitute, okay, we can substitute the values, that is the m2. What is the m2 there? That is 20 minus then m1 10 divided by 10 plus 20. Then what is u2? Minus 10, okay, minus 10 plus 2 into 10 divided by 10 plus 20 into 20. u1, that is the 20, okay. So we can get the answer 10 meter per second. So this is the velocities of the two balls after collision in the elastic collision. Clear? So you just remember the formula V1 and V2. Okay. Question number 2. A railway carriage of mass 9000 kg moving with a speed of 36 km per hour collides with a stationary carriage of the same mass. After the collision, the carriages get coupled and move together. What is their common speed after collision? What type of collision is this? Here the question consists of a railway carriage of mass 9000 kg. We can write m1 equal to 9000 kg moving with a speed of 36 km per hour. Its initial velocity u1 equal to 36 km per hour. Change it into meter per second by multiplying it with 5 by 18. You will get the answer u1 equal to 10 meter per second. It collides with a stationary carriage of same mass. Therefore, m2 equal to 9000 kg and stationary carriage of same mass. So, u2 equal to 0. Then you want to find out after the collision, the carriages get coupled and move together. What is their common speed after the collision? After the collision, they are moving with a common speed. Therefore, v1 equal to v and v2 equal to v. You want to find out this v. We apply the conservation. Here we can apply the conservation of momentum. By the conservation of momentum, what is the formula? Momentum before collision is equal to momentum after collision. So, what is the momentum before collision? m1 u1 plus m2 u2. What is the momentum after collision? m1 v1 plus m2 v2, where v1 and v2 are v. Therefore, we can write m1 v plus m2 v, and we can take the v outside. Therefore, we can write m1 u1 plus m2 u2 equal to m1 plus m2 into v. Then by substituting the values, we will get the velocity of the carriages after collision v equal to 5 meter per second. Now you want to find out what type of collision is this. So to find out the what type of collision, you want to find out the kinetic energy. Okay. So with respect to the kinetic energy before collision and after collision, we want to conclude that what type of collision, is it elastic or inelastic? Clear? So you studied that in the elastic collision, there is no loss of kinetic energy, but in the inelastic collision there is loss of kinetic energy. We can find out the kinetic energy before and after collision. So what is the total kinetic energy before collision? Formula is half m1 u1 square plus half m2 u2 square. Then substituting the values, we will get the answer 4,50,000 joule. Similarly, total kinetic energy after collision. What is the formula? Half into m1 plus m2 into v square, because it is moving with a common velocity after collision. So, by substituting the values, we will get the answer 2,25,000 joule. So, what do you understand from this? Total kinetic energy after collision is less than total kinetic energy before collision. So, here we can write total kinetic energy after collision less than total kinetic energy before collision. So here some loss of kinetic energy is there. Clear? Because kinetic energy after collision is less than kinetic energy before collision. So there is some loss of kinetic energy is there. So kinetic energy is not conserved in the collision. So we can say that the collision is inelastic. There is some loss of kinetic energy is there. Clear? Third question, a ball moving with a speed of 9 meter per second strikes an identical ball such that after the collision, the direction of each ball makes an angle 30 degree with the original line of motion. Find the speeds of the two balls after the collision. Is the kinetic energy conserved in the collision process? The question, according to the question, we draw the figure. So, a ball moving with a speed of 9 meter per second, u1 equal to 9 meter per second. Let the mass of the ball be m and the second ball stationary, that is u2 equal to 0. Then after the collision, the two balls moves with a velocity v1 and v2 with an angle 30 degree with the original line of motion. So after the collision, the velocities of the ball splits into two components. One is the v1 cos theta 1 and then v1 sin theta 1, and here also v2 cos theta 2 and v2 sin theta 2. Okay. So we can apply the conservation of momentum along the x-axis and along the y-axis. Then we can find out the velocities of the balls after the collision. So first we can apply the conservation of momentum along the x-axis. So what is the formula? m1 u1 plus m2 u2 equal to m1 v1 cos theta 1 plus m2 v2 cos theta 2. This I explained in the theory part. So you just go through the last class video. Then we can apply the values. It is m1 and m2, that is m. So m into 9 plus m into 0 equal to m v1 cos 30 plus m v2 cos 30. Therefore, m into 9 equal to m v1 root 3 cos 30 equal to root 3 by 2 plus m v2 root 3 by 2. Therefore, m into 9 equal to m root 3 by 2 into v1 plus v2. Therefore, v1 plus v2 equal to then 9 into 2, that is 18 divided by root 3 equal to 6 root 3, that is equation number 1. Similarly, we can apply the momentum along the y-axis. What is the consideration of momentum along the y-axis? Momentum before collision equal to momentum after collision. So, what is the momentum before collision along the y-axis? That is 0, because there is no movement along the y-axis. Therefore, we can write the formula 0 equal to m1 v1 sin theta 1 minus m2 v2 sin theta 2. Therefore, 0 equal to m v1 sin 30 minus m v2 sin 30. Okay, so sin 30, that is equal to 1 by 2. So, we can apply 0 equal to m v1 1 by 2 minus m v2 1 by 2. Then we can take the m into 1 by 2 outside. So, 0 equal to m into 1 by 2 into v1 minus v2. Therefore, v1 minus v2 equal to 0. Then we get v1 equal to v2, equation number 2. So, from this equation 1 and 2, equation 1 is v1 plus v2 equal to 1. Equation 2, v1 equal to v2. So, from this 1 and 2, we can substitute the value of 2 in equation 1. So, we get 2v1 equal to 6 root 3. Therefore, v1 equal to 3 root 3 meter per second. So, there v1 equal to v2. Therefore, v2 also equal to 3 root 3 meter per second. Clear? Second part of the question is the kinetic energy conserved in the collision process? For that, you want to find out the total kinetic energy before collision and total kinetic energy after collision. Total kinetic energy before collision is equal to half m1 u1 square plus half m2 u2 square. Substitute the values, half into m into 9 square plus 0, that is equal to 81 m divided by 2 equal to 40.5 m. Then total kinetic energy after collision. What is the formula? Half m1 v1 square plus half m2 v2 square equal to half into m into 3 root 3 square plus half into m into 3 root 3 square. Then half m, take it outside inside the bracket, 3 root 3 square plus 3 root 3 square. Therefore, we get the answer 27 m. So, from this equation we can find out total kinetic energy after collision is less than total kinetic energy before collision. Therefore, we can confirm that kinetic energy is not conserved in this collision process. Clear? Fourth question, two bodies of masses m1 and m2 have equal kinetic energies. What is the ratio of their linear momentum? Here, two bodies of masses m1 and m2 have equal kinetic energies. Therefore, we can write half m1 v1 square. This is the kinetic energy of the first body is equal to kinetic energy of the second body. You want to find out what is the ratio of their linear momentum. Then from this question, we can write v1 square divided by v2 square equal to half and half, we can cancel. Then m2 divided by, okay, m2 divided by m1. m2 divided by m1. Therefore, v1 by v2, okay, v1 by v2 equal to root of m2 divided by m1. Then this equation here, in this equation you can multiply with the m1 on both sides and divide by m2 on both sides. Therefore, m1 v1 divided by m2 v2. Similarly, on next side also m1 by m2, then root of m2 divided by m1. Clear? So, what is m1 v1? That is the moment of the first body. What is the m2 v2? Moment of the second body. p1 by p2 equal to, and here the root of m2 by m1. So, here we can write m1 as root m1 into root m1. So, root m1 and 1 root m1 will cancel. Then the numerator m1. Similarly, denominator m2. So this is the ratio of the linear momenta of two bodies. P1 by P2 equal to root m1 divided by root m2. Clear?